Yes. So let us discuss a very small concept of capacitors. To start with, couple of points which you people are already knowing. We have a parallel plate capacitor. The distance between the two plates is D, and each plate is having area A. Okay, so this particular case we are going to see now. We all are knowing the capacitance of this particular parallel plate capacitor is going to be A epsilon naught by D. Fine. Now, second point in this particular case is the same parallel plate capacitor between 2 points P and Q we are going to consider. This is the same capacitor, distance is D, area of each plate is A. Okay, now we are going to introduce a dielectric slab between the plates which has dielectric constant K. Okay, this is the dielectric introduced between the parallel plate capacitor. Now for this case also, the capacitance of this capacitor C is going to be A epsilon naught K by D. Due to this dielectric K, the change in the formula which was initially, this is the change occurred. This point also we all are knowing. There is no problem between these 2 points. First point as well as the second point. Okay, now why we are going to discuss this point is because of the point where instead of one dielectric, if we introduce multiple dielectrics between the plates of a parallel plate capacitor, what will happen? Fine. So the same capacitor we are going to consider. This is point P. This is the same plate of the capacitor. Q point. This is P point. We are going to introduce two different dielectrics. This is the first dielectric with medium dielectric constant K. This is the second dielectric with dielectric constant K2. Fine. Now, this particular problem we might be finding it difficult to solve. Let us consider this is very simple point. Now, if we concentrate on this particular capacitor, it seems simply as two capacitors connected in series combination. Okay, how they are connected? This is the capacitor with constant K1. This is the capacitor with constant K2. This is K1, this is K2, dielectrics between the plates. Okay, now the total distance between the capacitor is D. Okay, now let us say this distance is D by 2. That means half the distance is filled with K1 and the other half distance is filled with dielectric K2. Okay, now this particular part is this one, this particular part is this one. Fine. Now if I want to find the equivalent capacitance, I find 1 upon C equivalent is equal to 1 upon C1 plus 1 upon C2. Fine. Series combination of capacitors, we find 1 upon C1 plus 1 upon C2. To find this combination equivalent capacitance, we must know the value of C1. Now, as we found the value of capacitance C in this case, we are going to find the value of C1 as well as the value of C2. Okay, so concentrate on these 2 points. C1 in this case will be equal to, yes, you all are knowing, it will be A epsilon naught K1 by D upon 2, D by 2. Why D by 2? Because the distance, concerned distance is D by 2. Fine. Similarly, the C2 value will be equal to A epsilon naught K2 by D by 2. Fine. Simplifying these two things, C1 becomes equal to 2 verticile twice A epsilon naught K1 by D, and the C2 value becomes equal to twice A epsilon naught K2 by D. Fine. So these are the simple things which we are knowing. Now we are going to find the equivalent capacity of this. So 1 upon C equivalent is equal to 1 upon C1 plus 1 upon C2. So simplifying, we are going to get value substitute karo beta 1 upon 2A epsilon naught K1 by D plus 1 upon 2A epsilon naught K2 by D. Fine. Now further, this D goes in the numerator, it becomes D upon twice A epsilon naught K1 plus D upon twice A epsilon naught K2. Now addition करण्यासाठी दोन्ही व्हॅल्यूचा LCM काढायला लागेल. LCM काय येईल? LCM becomes equal to twice A epsilon naught K1 into K2. या टर्ममध्ये K2 नाही आहे, तर ही व्हॅल्यू होणार आहे D इंटू K2 प्लस ही व्हॅल्यू होईल D इंटू K1. फाइन. सो लेट अस सिम्प्लिफाय दिस फर्दर. इट इज गोइंग टू बी 1 upon C equivalent is equal to, we are having the value D K2 plus D K1 upon twice A epsilon naught K1 K2. Okay, so 1 upon C equivalent becomes equal to D taken common outside 2A epsilon naught, it becomes K1 K2 plus K1 upon K1 K2. So C equivalent is equal to twice A epsilon naught K1 K2 divided by D into K2 plus K1 or K1 plus K2. This is your concerned answer. Fine. Now in this only, the next case which comes is case number 4th. If I take the same capacitor, this is point P, this is point Q, this distance is D. Now the dielectric is introduced in this particular form. Fine. Now how it is introduced? This particular dielectric is K1. Fine. This particular dielectric is K2. Okay. Now what is happening here? This total area जो A होता, आता हा एरिया होणार आहे A by 2 आणि हा एरिया होणार आहे A by 2. Let us say half of the area is filled with K1 and other half of the area is filled with K2. Now if we practically look, this forms similar to a parallel combination of two capacitors. That means this is going to be a simple structure. This is Q, this is P. This particular is filled with K1 and the other half is filled with K2. Right? Now for a parallel combination, C equivalent is equal to C1 plus C2. Fine. So let us find the value of C1 now. C1 is equal to, आपल्याला माहिती आहे आपण कसं काढतोय, A by 2 epsilon naught K1 into D. है ना. एरिया a by 2 झाला. a epsilon naught by d घेतो आपण. एरिया a by 2 epsilon naught k1 आणि d. Right? Similarly, C2 value becomes equal to a by 2 epsilon naught k2 into d. Okay, so the combination equivalent value is equal to C1 plus C2, so it becomes equal to a epsilon naught k1 by 2d plus a epsilon naught k2 by 2d. Okay, so this value is C equivalent is equal to a epsilon naught by twice d taken common outside k1 plus k2. This is your concerned answer. So now once you revise this, we will solve numericals on this particular case. Thank you.